Welcome to the studio here. I'm so glad that you could join, or that I could join you virtually, as it were. I'd much rather be there with Francois, but thanks for letting me jump in this way. So what we want to do for you is a quick demo today that is all about an existing business network that has just suffered a breach of some kind, and so we are now doing incident response work. And our goal is to deploy a zero trust connectivity solution for some immediate remediation. And so we have two main goals that we want to achieve. Number one, we want to make sure that we go radio silent to the attacker, that the attacker has absolutely no way of reaching into the network anymore for any status updates or to launch any further attacks. Number two, we want to get critical infrastructure up and running as soon as possible so business can resume, and then every next step that the post-breach response team needs to follow can still do everything they need to do. So to achieve these two goals, we need to sever every connection possible, and we also need to automatically quarantine every single asset on the network, and then only give full access to verified and necessary devices that need to get back online, and then allow the forensics team to continue their work. So that's the goal here. So let me give you a quick visual tour of what we're working with here today. What we have is a PLC that has vulnerable firmware, so it might have been the point of entry. We have an Inkbird, which is a Wi-Fi Bluetooth bridge. We have some Android devices that need to get online over Wi-Fi. And we have an Ethernet connection that's going to the rest of the infrastructure, so the rest of layer 2 connected devices, switches, and so forth. We also have a small managed switch here, and we have a conventional security gateway that's currently providing internet access to this business here. And we have green and yellow cables that are internal connections and red cables that are internet connections. Now, the star of the show is this guy here. Yes, it is the label that does the trick. It's a Zero Trust Gateway running ADAM1, and here we support up to 10 gigabit of layer 3 traffic. We have SD-WAN support for multiple internet connections, failover, load balancing, all that fun kind of stuff. All right, I'm ready to show you now a part of our demo. So the demo, we're going to go back to our screen here, and we will start with this dashboard. This is the ADAMnetworks dashboard that basically shows you that it is a multi-tenant account here, a multi-network location. This is our demo location today at blackhat, and we have a default policy that we're looking at here that all newly discovered devices will be treated with. It's the default. So when a new MAC address is discovered at layer 2 or 802.1x authentication happens, the default happens if there's nothing assigned to it already. This is how it's going to be treated with this specific policy. And the 0 there means that there currently aren't any there at all. But we have pre-staged some equipment. So we do have some equipment pre-staged, for example, in the DNS Harmony aggregation policy. This is where we're basically saying, well, instead of relying only on one threat intelligence source, let's rely on Cloudflare for Families, which is malware and adult content protection, AdGuard DNS, that does third-party advertising servers blocking. Clean Browsing has got good machine learning resources. Quad9 is another free resource. And, of course, our favorite commercial threat intelligence source, BrightCloud. So when anybody who's treated with this policy needs to be able to reach out to a destination, whether that's an IoT device or an end user, it needs to pass those 5 tests, and unless it's overridden by any one of these block lists that also apply to it. And you'll also notice that we have a BrightCloud reflex listing policy, and in this case, only these allow lists, or if treated by one of these always allow or allow categories, will those devices then be able to reach out. So unknown domain names or ones that are not categorized yet will simply be in a block or always block scenario. So those are the different policies that we have running here. And then finally, we have our red team tool. This is a command and control server called Sliver, and we have some implants. And the one implant I'm running here today is called Yellow Apple, and it is going to a C2 infrastructure that we're running here. And so we're going to come back to this screen when we have done our cutover, and then we'll take it from there. So now let me go to part number 2. What we're going to do here is we're going to disconnect this particular one here. This is the conventional gateway, and it's coming out. And what we'll do instead is we'll connect this one here. This is now having the exact same network that was treated with no protection before, is now being treated successfully. Our desktop here, and you'll notice that we had a couple of missed pings as we did the swap, and that's to be expected. But let's also watch some and launch some live DNS logs. What we'll do here is we're looking specifically for anything that is now trying to reach out to the internet that maybe is not allowed. And you'll see that the connections that are over a red connection are blocked, and the ones that are in green are permitted. We're also going to launch a traffic log, and the traffic log will actually show real attempts of traffic that have nothing to do with DNS. And so when you see all these red block connections at the ports, it's very telling that you have attempts at various SSH and DNS tunneling that are happening that are all being blocked. These are attempts that are all failing, but anything that's in green is coming through fine. For example, access to the dashboard here is being allowed through, but not everything else. And so this is exactly what we were expecting. But now what we want to do is take a look and see if we have any sessions left on our C2. And look at that, they're all dead. So the C2 has now been completely severed. There's no more access anywhere. Although connections continue to be attempted here, as you can see. Now, the last part here, I want to show you what happened to all those devices that were just discovered when we connected. We now have 6 devices that are showing up on the holding tank, including, I happen to realize, this is the one that's infected with a C2, right? But it's in the holding tank, and that's why we're able to spot that it is not able to reach out at all. And we also have these other devices that join the network, but they're also in the holding tank. So until they are looked at individually on an individual basis, they cannot be moved. However, if one of them is deemed to be safe because it's a virtual machine that is not infected, it is as simple as taking it back to another policy and saying that this is a verified VM, and we make it come over to a place where it's got internet access. And so it's now in place where it has access to continue to offer critical infrastructure services. The incident response team at this point can take its normal course of doing further forensics and use this as a tool to indicate what devices are still generating network traffic that is questionable. And this is where a quality threat intelligence feed is super helpful, because what it does is it shows us the exact categories of destinations that a device may be attempting to go to. So if we were to visit, for example, blackhat 2022, we would see that those domains showed up. We can pause this, by the way, and you can see that blackhat is categorized as computer internet information. This is coming from BrightCloud itself. And that concludes my demo today. Since you're watching this particular version, there is no Q&A, but on the live version, if I do another one of these, there'll be time for questions, and I'll look forward to engaging with you. Take care, and hopefully you guys enjoy the rest of your time at blackhat. Bye for now.